Figure out what our sun would need to be in order to become a black hole. We're going to use the exact same formula. The radius of our sun as a black hole. 2 times 6.67 times 10 to the negative 11th. The only thing that's changing is the mass. The mass of our sun is about 2 times 10 to the 30th kilograms, divided by 3 times 10 to the 8th squared.
That's our sun. What's the under R? The subunits of R?
Sun BH for black hole. Yes, now it's clear. You have young eyes. You should all be able to see it. Okay, people without glasses have an excuse. Or people with glasses have an excuse. It's more than a millimeter, I know that.
2,964.4 meters.
So a little under 3 kilometers. I'm pretty sure that's right based on memory. If you're getting something completely different, then either try to figure out your mistake or at the break, we'll try to figure it out. So that's what, Peters Creek to here? Is that about 3 kilometers? I don't know, maybe Peters Creek to Haynes Mall. So if the sun somehow collapsed down into that size, the sun would become a black hole, and the fact that anything that got to it would not escape. First off, our sun is not expected to do that. But let's pretend for a moment. If our sun suddenly, our theories were wrong, no, change that. Our theories about stars were wrong. Let's assume all the rest of our knowledge of physics was right. If our sun suddenly became a black hole, what would the Earth do?
Be sucked into it.
And that is a common misconception. Because we are being pulled around the sun based upon the gravitational pull, which is based on the mass of the sun, which hasn't changed. Only thing that's changed is the size. The Earth would continue to orbit. Now, it would get really dark here, and it would get colder, and eventually the plant life would die, and we probably have about a month to live. Yeah. Not as depressing as when we talk about the second law of thermodynamics. That's the really depressing one.
Wouldn't we also freeze to death?
The Earth generates heat, so I don't think we would freeze to death first. I think we would starve to death, but I don't know, and who can never find out.
He flew in my face, just a ladybug.
It was blood I was talking about. That. I don't know, I think it was a little bit bigger.
Sorry,
than
I'm
that
just
thing.
gonna let him fly around.
So I'd be free. When I was teaching in Columbia, South Carolina, there was a cockroach shocking if you've lived in Columbia, South Carolina. There was a cockroach in the building, and one of the other teachers picked it up and was going to take it outside. I thought, kill it. Ladybugs and Asian lady beetles, fine, but cockroaches, just kill them.
I think there's also a stink bug in here somewhere.
Kill them too, except do it carefully because I don't want to smell it. All right, so now, what's going on with the sun? I don't think I've talked about the process, or stellar processes. But you got two things going on in stars. There's this gravitational pull in, because it's a lot of mass. There's a gravitational pull inwards. At the same time as what's going on chemically is we've got two hydrogens that are smashing together. There's enough heat, they will smash together. And what they produce, the two hydrogens, what they will produce has less mass than what they started with. So, once they have joined like that, that extra mass that is lost goes into energy. And so there's energy working its way out. So when these two processes are battling. Now, once all the hydrogen is used up, the next bit of elements that will then start to combine will be heliums. The heliums will come together, they will smash into each other or join. Probably a couple hydrogen heliums will join, but once all the hydrogens are gone, heliums will join and create beryllium and give off some energy. But not as much energy as when two hydrogens meet. Matter of fact, the farther up you go, the less energy that is given off. And so as hydrogen burns up, and we're left with the other chemical elements, we're still having this radiation going outwards, but it is not as much. So the gravitational pull will start to sort of win there. But at the same time, we're losing mass. So the gravitational pull becomes a little bit less also. So it's a question of which one starts dropping off faster. Our sun is expected to lose mass faster than the energy coming out from the radiation. So our sun is expected to actually get bigger. Eventually, our sun will be here. We will not be. And you can interpret that two different ways. Humans are not expected to be around at that point. And also the Earth, as the gravitational pull from the sun lessens, the Earth should be moving farther out. So eventually the sun will be here, the Earth will not be. Some people will say that the Earth will eventually get burned up by the sun. No, but the spirit of what's being said is true. Now, if there's enough mass in the sun, or in the star, then the gravitational forces will take precedence and the thing will collapse in on itself. If it collapses in slowly enough, then you end up with the neutron star, you end up with these incredibly dense stars, not enough for a black hole. If they come in crashing in fast enough, they will create so much heat that they will then explode and you get novas and supernovas. If there's even more mass past that, the thing will collapse in on itself. There's too much gravitational pull, so the explosion will not send the pieces out and create novas and supernovas, but you'll get a black hole. And some of this is laid out, probably better with a second law of thermodynamics. There's a video by Melody Sheep. I don't know if you've seen it, about sort of the future of the universe. No, okay. It's a half-hour long, I think it's well worth it. It's not a happy thing. But
isn't it like a certain number of years, like expected to like essentially what you're saying, like explode the Earth?
and a couple of, you say the Earth's going to explode?
Yeah, I don't know the number of years, but like it's like a certain number of years.
There's nothing that I have ever seen to make me think that the Earth is going to explode.
No, maybe it's a different video I'm thinking of.
It could
I
be.
don't know that it's educational or true. I just feel like I watched one that said that. Because of
I believe that was the movie, one of the Planet of the Apes movies.
The effects of global warming, something about it.
Global warming is not going to affect the planet itself. The Earth's still going to be going around. It might kill all life on the planet, but the planet itself is going to be fine. I assume the planet does not need humans on it, or any animals.
So when are we selling those tickets to Mars again? Hope it's.
I guess they picked the first group who volunteered to go, and then I'm not quite sure what happened after that. There was a big hoopla a couple years ago.
There was like talk of them finding life on another planet too. Recently, like on CNN.
Oh.
Yeah.
I had not seen that.
Potential signs that there may be something living on another planet.
Wasn't it like microorganisms?
Yeah.
Ah.
See them?
Because there's a thing about there's this something that came from Mars that had some signature that could be an indication of having life on Mars, which the scientists said there's some evidence to suggest, which the reporters then took as life on Mars.
Probably.
So I'm somewhat skeptical. Any questions about black holes or escape speed?
Why do we think that we're gonna be pulled in by a black hole?
Oh, let me address that. All right, so if our sun became a black hole, just for a visual, the sun becomes a black hole, it still has, assuming the same amount of mass, Earth's still gonna go orbiting it without knowing any different. If a particle in space gets close enough to the sun, it will, so Earth's going around like this, it's not getting really any closer, but if an asteroid or something like that came in here, it would go into the sun, and suddenly the mass of the black hole becomes a little bit bigger. So as the mass of the black hole gets bigger, then, well, things will start getting pulled in closer. So potentially, if enough things, so think about the vastness of space and the chances that something's gonna fly along, happen to be flying close enough towards the sun that it's gonna get sucked in. And at the same time, the other thing that's going on with black holes is this radius here, by the way. I'm gonna connect this back in just a second. It's known as the Schwarzschild radius, or poorly pronounced, but Schwarzschild radius. During World War I, guy, German physicist, Schwarzschild, I feel like I'm missing a T there. Close enough. Was suffering from a mustard gas attack and was recuperating in the hospital. And so what do most people do when they're recuperating in a hospital for mustard gas? They look at physics. He did manage to produce two, that doesn't look right either. Two significant papers while he was recuperating. He ultimately does not survive the war. One of many notable physicists who did not survive the war. But two significant papers, one of which was to look at gravitational pull and, in essence, black holes. Okay. So when you have a black hole, the size of the black hole is generally characterized by the Schwarzschild radius. Now, if you're just outside the Schwarzschild radius, there's a chance to escape, if you're going fast enough. Now, if I suddenly popped in near that, I'm not going fast enough, I'm getting sucked in. As you get sucked in over the event horizon, that's what this is right here, over the event horizon, at that point, the gravitational pull at my feet would be different than at my head, significantly. And I would start to get stretched out. I would not be alive for this, so, and no one's actually experienced this. This is based on theory. Now, if you're just outside it, it is possible, there's a lot of energy floating around there, that particles can be created out of what seems like nothing. If I have enough energy, I can create particles. We can do this in a lab. It's happening probably around us right now. It's not happening significantly. It's not like we're getting bombarded with all these tiny little particles. Well, whatever you're thinking the number of particles are being bombarded by, it's not as many as that. So if you produce a particle here, these are tiny particles, subatomic particles. They'll be traveling near the speed of light when they come into existence. And one of them will get sucked into the black hole and the other one will get potentially shot out. The stuff that gets shot out, that's sort of what we're looking for when we want to see if there's a black hole. In essence, this is known as Hawking radiation, named after Stephen Hawking. Because we are losing mass here, because this is mass associated with the black hole, even though it's not on the wrong side of the event horizon, it's losing mass, so black holes, given enough time, will eventually disintegrate on their own. So now the question is, will new mass come in that stray asteroid or whatever, come into the black hole at a faster rate than it's losing mass around the edge. There seem to be some black holes that are rather stable, and that, yes, they do seem to get more stuff in there than they're getting rid of. But given enough time, they'll eventually all disintegrate.
Where do black holes lead?
Okay, so I've heard two basic thoughts on that one. Black holes will lead to just being crushed to death, and that, ultimately, it's what physicists call a singularity, which just mainly means that when you work out the math, you end up dividing by a 0, and you go, whoa, can't do that. So physically, the classic black hole is that there's just some massively dense material there in the middle of it that you eventually end up there. Some theories say that there's this thing called white holes, and that if you go into a black hole, you'll get shot out at some other place out of a white hole. Black holes like can't escape. So black holes like cannot escape. White holes like can't stay. Everything's ejected from white holes. So it's not like we've seen them. But it's not necessarily unallowed, so therefore theoretical physicists can play with it.
How could it get shot out if it gets absorbed by the black hole? Because I can say the mass grows when something gets put into it.
Yeah, I'm not 100% sure of that one. This is well beyond anything I've really studied. I just pick up stuff on the streets, but to me, it's a legitimate question that I just don't have the answer to. Did I answer your question, Rebecca? Did I? Ish. You asked where do they lead? Okay. So at least I was in the ballpark. At least my answer had something to do with your question, if not satisfying. All right, why don't we take a break there? And I'm realizing that that clock is still an hour off. So I will adjust that. And Erica, I wanted to figure out your calculator issue, and anyone else. And it'll run for now. I would apologize that I might be reading.
I have my test questions.
Oh, yes, please.
I don't know.
Is your name on all the loose pieces of paper?
It's just for extra work.
Okay, if you just put your, at least initials or first name, just email so that in case it gets separated. Oh, okay, thank you. All right. Oops, sorry. Thank you.
I didn't know how you, I don't know how to fix that. What is the matters?
Oh, okay.
On mine, the back page.
I mean, test questions, you're not required to do everything. Right?
Well, I didn't know how to do that, so I did everything else, so.
Okay, all right, thank you. You got to hand in something. Oh, okay.
There comes Sean on the little box there. So.
Do you have anything to give back to me for last week?
Quite possibly. Sorry, there's something for Zoe also.